So next we can see the incident and reduced incident matrix. Okay, incident and reduced incident matrix. We can see one problem, then you can understand. So what do you mean by incidence matrix? Okay, what do you mean by incidence? It is the interconnection of an oriented graph. Okay, it is represented by node to branch. Okay, it is the interconnection of the oriented graph. So when the branch leaves the node, you want to mark it as +1, and when it is enter the node, you want to mark it as -1, and if it is not instant means you want to mark as 0. Okay, so reduced means, so you want to remove the number of rows வந்து reduced by 1. So that is known as the reduced incident matrix. So you want to delete the rows which is correspond to the reference node, 0th node, that is the reference node. So you want to delete the row which is corresponds to the reference node. So that is known as the reduced incident matrix. Okay, so now we can see one problem. Obtain the node to branch incident matrix and its reduced incident matrix, and also write KCL KVL equation from the given graph. Okay, so it is the graph, it is the given graph, so you want to write the incident matrix. Okay, so here how many nodes are there? 0th node, first node, second node, and third node. So 0 1 2 3 4 nodes, and how many branches? 1 2 3 4 5 6 branches. Okay, so 3 nodes and 6 branches, 4 nodes and 6 branches. So here 4 nodes and 6 branches. Okay, so write the nodes in the column and branches in the row. So now first consider the node 0. First consider the node 0. So node 0, what are the branches located? What are the branches located? The branches is located are 1, 3 and 4. Okay, so branch 3 la enna node 3 la enna branches la located irukku? 1, 3 and 4. So node 0 la branch 3 வந்து என்ன ஆகுது? enter ஆகுது. branch 1 வந்து என்ன ஆகுது? leave ஆகுது. branch 4 வந்து என்ன ஆகுது? enter ஆகுது. Okay, so branch 3 is entering, branch 1 is leaving, and branch 4 is also entering. So you want to write in a 0th node, what are the branches? 1 3 4. So 1 3 4. So 1 is leaving. So leaving means you want to mark as +1, and 3 is entering. Entering means -1. 4 also entering, so -1. Next in branch 1, what are the branches? So remaining branches, the value is 0. So what are the branches which is at the node 1? The branches which is located at the node 1 is 1, 2 and 5. Here 1 is entering, 2 is leaving, and 5 also leaving. Entering node -1. Okay, 2 is leaving node, so 1, and 5 also leaving node, so 1. And next in node 2, what is the node 2? What are the branches located? Branches are 2, 6 and 3. 2, 6 and 3. So 2 is entering, so -1, and 6 is leaving, so 1, and 3 also leaving 1. So remaining all other nodes are 0. Okay, so similarly for node 3 also you want to write the value. Okay, so node 3 ku adhe mari eludano, and this is the incident matrix. Okay, this is the incident matrix, and next you want to write the reduced incident matrix. Okay, next you want to write the reduced incident matrix. So how will you write the reduced incident matrix? So I said you, the reduced incident matrix means you want to delete one row. Okay, you want to delete one row. So for that you are deleting the reference node. Okay, so reference node means that is the 0th node. 0th node la ulla values enna pananum? Delete panni eludhanum. Okay, so what is the value? Remaining value -1, 1. Okay, -1, 1 0 0 1 0. Okay, and remaining 0 -1 1 0 0 1. Then 0 0 0 1 -1 -1. Okay, so you are deleting the reference node and writing the remaining values. Okay, 1 2 3 4 5 6. Can you understand? Okay, so this is the reduced incident matrix, and next you want to write the KCL and KVL equation. Okay, you want to write the KCL and KVL equation. So how you can write the KCL equation? So Kirchhoff's current law equation. So the value is the incident matrix into the current, which is equal to 0. Okay, so incident matrix N cross M and B cross 1. Okay, so here what is the incident matrix value? Minus 1. That is the reduced incident matrix. Okay, remember that reduced incident matrix. So minus 1 1 0 0, 0 minus 1 1 0 0 1, and the remaining value 0 0 0 1 minus 1 minus 1. Okay, and what is the current value? Total current values are 6. Okay, that is the branch currents, that is 6 branch current. Okay, so I1 I2 I3 branches are represented by the branch currents, that is I1 I2 I3 I4 I5 I6 equal to 0. Okay, so now can you multiply this value? So first current value is minus I1 plus I2, which is equal to plus I5 value is also there, I5 equal to 0, first current equation. Next minus I2 plus I3 plus I6 equal to 0, and the next value is I4 minus I5 minus I6 equal to 0. So these are the KCL equations. Okay, Kirchhoff's current law equations. And next KVL equation. So what is KVL equation? So in order to write the KVL equation, you want to so next is the KVL equation. So in order to write the KVL equation, you want to transpose the incident matrix. Okay, so you want to transpose the incident matrix. So transpose panam into the voltage value. Okay, into the voltage value. So that is that is V which is equal to B cross 1, which is equal to A transpose value into E value. Okay, into E value. So now voltage. So how many voltage? V1, V2, V3. So totally 6 branches. So there are 6 voltages, V1, V2, V3, and you want to transpose this reduced incident matrix. Transpose the rows are changes to column and columns are changes to rows. So you are transposing, then you got minus 1 0 0, 1 minus 1 0, 0 1 0, 0 0 1 அப்படியே டிரான்ஸ்போஸ் பண்ணி எழுதணும். ஓகே, இந்த காலம் ரோ மாறும். ஸோ minus 1 0 0, next 1 minus 1 0. Okay, so 0 0 1, then 1 0 minus 1, then 0 1 minus 1. Okay, 0 1 minus 1. So how many nodes are there? 3 nodes, correct? Okay, 3 nodes in instant matrix. So the voltage is potential value is E1, E2, E3. So now the KVL equation is V1 equal to minus E1. Multiply this value, minus 1 into E1 minus E1. Then V2 value is E1 minus E2. Then V3 value is E2. V4 value is E3. Then V5 value is E1 minus E3. Then V6 value is E2 minus E3. So these are the KVL equations. Can you understand? So this is the KCL and KVL equations we want to write from the incidence and the reduced incident matrix. Okay.